Alright, so this is a start of Unit 7. Classifying polygons is what we're looking at today. And we want to classify a polygon based on the number of sides and angles, identify the number of diagonals given in a polygon, determine if it is concave or convex, and determine whether it is regular or irregular. So a polygon is a closed plane figure formed by 3 or more sides. And when we name our polygon, we want to list our vertices in consecutive order. So for example, A, B, C, D, and E is a name for this polygon, but you could also do C, D, E, A, B, just depending on where you start, as long as you list them in consecutive order. We can have two types of polygons, convex or concave. And your convex polygon, all interior angles are less than 180 degrees. So all of the vertices are going to point outwards. It's not going to be caved in like a concave. I think of a cave, if somebody's punched in the side, or you can think a polygon with dents in it, and where at least one of the internal angles is greater than 180. So for example, this angle here is greater than 180 degrees. So therefore this is a concave polygon. So let's identify a few figures and tell whether they are convex or concave. So in number 1, this would be concave because it's sunken in at the top there. Number 2 is not a polygon because it's got a curved side. Polygons cannot have curved sides. Number 3 is also not a polygon because it's got this split down the middle. So if this was not here, we could call it a concave polygon. And number 4 is a polygon, and it is convex. Alright, now sometimes you might hear a polygon referred to as an n-gon. And an n-gon, n is just referring to the number of polygon sides that's used to name the polygon. So for example, once you get above the common names for polygons, we usually just call them a 13-gon or a 20-gon. If a polygon is equilateral, that means all of its sides are congruent and it should be marked accordingly. If it is equiangular, all interior angles are congruent and they would be marked accordingly. And if you have a regular polygon, it is convex. That's important that you understand that only convex polygons can be regular. And it has to be both equilateral and equiangular. Concave polygons can be equilateral and equiangular simultaneously, but because they're not convex, it will not be a regular polygon. Okay, so let's classify some polygons. We want to decide if it's equilateral, equiangular, or regular. So in example 1, this is a convex polygon. It is equiangular because all 4 angles are right angles, but it is not equilateral, so therefore it cannot be regular. Alright, this has all equal sides, so it's equilateral. It has all equal angles, so it is equiangular, which means this is a regular polygon. And then last we have a triangle. By the way, triangles are always convex, but none of its sides are congruent, making it scalene, and none of its angles are congruent. So this is a convex polygon, but it is not equiangular or equilateral. All right, here we have a regular pentagon. We want to find the length of each side. Well, if it's regular, then I know that this side and this side must be congruent. So I can set them equal to each other. And then solve for x. So x is equal to 4. And if x is equal to 4, I can plug this in here, and that means each side is 7 centimeters long. All right, do the following practice questions and let me know if you have any issues. So number 1, not a polygon. Number 2, convex. Number 3, not a polygon. Number 4, concave. Number 5 is a quadrilateral and it's regular. And I didn't go over the different types of polygons, but see if you can remember some, starting with triangle, quadrilateral, pentagon, and so on. We'll be practicing that today in class. And then the last one, you were to find the length of a side. I just found x. X equals 5, and the side length is 16 millimeters. All right, let me know if you've got any questions.